From discarded metal and scrapped cars to molten steel, discover how waste transforms into the foundation of modern industry. At the recycling yard, end-of-life cars are prepared for recycling through a systematic process. First, all valuable and hazardous components, such as batteries, tires, and fluids, are removed to ensure safety and environmental protection. Once the vehicle is completely stripped, a powerful lifting machine raises the car and places it into a massive hydraulic press. This machine crushes the vehicle with tremendous force, flattening it into a compact metal block. The compression process reduces the car's volume significantly, making transportation and further processing easier. These crushed car bodies are then sent to metal shredders or steel mills, where they are melted down and reused as raw materials. Through this recycling method, a large portion of the vehicle's metal can be recovered and transformed into new products, promoting sustainability and reducing waste. The vehicle recycling system is a powerful hydraulic dismantling tool mounted on an excavator, specifically designed for recycling end-of-life vehicles in an efficient and profitable way. It consists of two main components: a robust grapple and a pair of clamp arms. These work together to dismantle cars quickly, safely, and with maximum material recovery. The process begins with the grapple lifting the vehicle from the ground and positioning it inside the clamp arms. Once the car is in place, the clamp arms close tightly to secure the vehicle, preventing any movement during dismantling operations. The grapple then starts by tearing off large external body panels, such as doors, hoods, and trunk lids. These components are set aside for sorting and further recycling. After removing the outer panels, the operator uses the grapple to access the interior and engine bay. The clamp arms may apply crushing force to flatten certain parts of the car, making it easier to reach inside. The grapple then extracts large, valuable components such as the engine block, steel suspension parts, and aluminum radiator units. Each item is removed with precision and placed into sorted material piles. One of the most important tasks is the recovery of non-ferrous materials, particularly copper wiring. With the vehicle firmly held by the clamp arms, the operator uses the grapple to rip out wire looms, dashboard electronics, and fuse boxes. These are placed in separate bins for copper recovery. The operator may also rotate or reposition the vehicle to access wiring hidden in the trunk or under the dashboard. The PowerHand VRS is also highly effective at removing catalytic converters, which contain valuable precious metals like platinum and palladium. Using controlled force, the grapple detaches the converter cleanly from the exhaust system. Throughout the dismantling process, the operator skillfully maneuvers the vehicle using the excavator arm, changing its orientation to reach all critical areas. Once all valuable components have been removed, including copper wires, aluminum parts, steel structures, and catalytic converters, the remaining vehicle shell is crushed or placed in a separate area for shredding. This system greatly increases efficiency, minimizes manual labor, and ensures high material recovery, transforming ELVs into sorted, valuable resources ready for further recycling. Scrap metal recycling in Perth, carried out by Allied Metal Recyclers, plays an important role in environmental protection and resource recovery. The company collects, sorts, and processes various types of metal waste, such as steel, copper, and aluminum. Through advanced recycling technology, these materials are cleaned, shredded, and prepared for reuse, reducing landfill waste and conserving natural resources for sustainable industry. Pacific Auto Recycling Center in Lancaster, California is a state-of-the-art facility dedicated to full-service, self-service, and vehicle recycling. Covering 17 acres with advanced drainage and filtration systems, it dismantles, salvages, and recycles vehicles, keeping harmful waste from landfills while supporting clean, sustainable automotive reuse. The GPS HS800 scrap shear represents one of the most advanced and efficient solutions in modern scrap processing technology. Developed by GPS Scrap Processing Systems, this heavy-duty machine is specifically designed to process light to medium-weight scrap metal, such as automobile shells, steel profiles, and light metal structures, into smaller furnace-ready pieces. Its dual capability to both shear and bale scrap materials makes it an indispensable asset for recycling facilities and metal processing yards seeking high productivity, operational efficiency, and reduced environmental impact. At the heart of the HS800 lies its hybrid diesel/electric power system, a hallmark of GPS's engineering innovation. This hybrid configuration offers the flexibility of using either diesel or electric power depending on site conditions and energy costs. It ensures not only lower fuel consumption and reduced emissions, but also smooth, reliable operation in diverse industrial environments. This environmentally conscious design reflects GPS's ongoing commitment to sustainability and energy efficiency in heavy machinery manufacturing. The main function of the HS800 scrap shear is to transform large, bulky scrap metal into manageable pieces suitable for melting in steel mills or non-ferrous smelting plants. It can process a wide range of materials, including low-carbon lightweight steel, automobile bodies, and light structural components. By breaking down these materials into standardized sizes, the HS800 ensures optimal furnace charging efficiency, improving both throughput and energy performance in subsequent recycling stages. What sets the HS800 apart is its exceptional processing capacity. Depending on the operational cycle, it is capable of producing up to 380 cuts per hour, making it one of the fastest and most productive shear balers in its class. This impressive rate allows scrap yards to maintain high daily throughput, reducing material backlog and maximizing the profitability of their recycling operations. Whether working in a stationary setup or a mobile configuration, the HS800 maintains steady performance even under heavy workloads. From a technical standpoint, the HS800 is built around a robust hydraulic system that delivers immense shearing force, ensuring smooth cutting through various grades of metal. The hydraulic cylinders are engineered for durability and precision, minimizing downtime and extending service life. The baling chamber and cutting blades are manufactured from high-strength steel to withstand continuous use, even with abrasive materials like car shells and mixed scrap. The combination of mechanical power and hydraulic control ensures efficient and clean shearing cycles. In terms of operation and control, the HS800 incorporates a fully integrated PLC-controlled system that harmonizes the machine's hydraulic, electrical, and mechanical functions. This smart automation enables intuitive operation, high reliability, and simplified maintenance. Operators can monitor system performance, adjust cycle parameters, and diagnose potential issues directly through the PLC interface. The result is minimized maintenance downtime and improved safety during operation. One of the most remarkable features of the HS800 is its remote control capability. The machine can be operated entirely by a single person using a radio remote control, allowing the operator to manage loading, cutting, and baling from a safe distance. This not only reduces labor costs, but also enhances workplace safety by keeping personnel away from potentially hazardous zones. The single operator system exemplifies GPS's focus on practicality and modern automation in scrap handling. Another key advantage of the HS800 is its customizability. The machine is available in several models with varying case lengths, each designed to meet different operational requirements. Customers can choose between configurations optimized for compact scrap or bulkier materials. Additionally, GPS offers optional attachments such as a preloading hopper to streamline material feeding and increase overall productivity. This flexibility ensures that the HS800 can be adapted to fit the unique workflow and spatial constraints of any scrapyard or recycling facility. From an environmental and economic perspective, the hybrid design and efficient operation of the HS800 translate into tangible benefits. Reduced fuel consumption, lower emissions, and minimized energy losses contribute to a smaller ecological footprint. Meanwhile, the high-speed cutting and baling cycles enable operators to process more material in less time, lowering cost per ton of scrap processed and boosting profitability. In practice, the GPS HS800 performs a vital role in the recycling chain. By transforming discarded vehicles, metal frames, and light structures into compact, furnace-ready feedstock, it helps close the loop in the metal life cycle. This efficient preparation of secondary raw materials reduces the demand for virgin ore extraction and conserves energy in steelmaking, thereby supporting sustainable industrial development. In summary, the GPS HS800 scrap shear is a cutting-edge, heavy-duty scrap processing system that combines power, precision, and sustainability. Its hybrid diesel/electric technology, single-operator remote control, and PLC integrated system make it an ideal solution for modern recycling operations. The impressive demolition of a large bulldozer using a heavy-duty hydraulic scrap shear, the VTNCI 7000, is a powerful industrial tool designed to be mounted on an excavator or other heavy machines. It is specially engineered for cutting and dismantling large metal structures, such as vehicles, machinery, and industrial frames, into smaller and more manageable pieces suitable for recycling. At the beginning of the operation, the excavator operator positions the machine close to the bulldozer that is ready for dismantling. The hydraulic scrap shear, with its strong and sharp jaws, is carefully lowered onto the first section of the bulldozer. Using high hydraulic pressure, the shear begins to slice through thick steel components with ease. Each movement of the jaws produces a clean, precise cut, separating parts such as the blade, cabin, tracks, and engine housing. The powerful closing force allows the shear to penetrate and tear through even the heaviest sections of the machine. The operator works methodically, rotating and tilting the excavator arm to reach all parts of the bulldozer. The VTNCI 7000 cuts through steel beams, fuel tanks, and connecting joints, reducing the structure step by step. The hydraulic system ensures continuous cutting force, while the rigid frame of the shear provides stability and precision during the entire demolition process. The operation proceeds smoothly, with minimal noise and vibration, demonstrating the efficiency and control of the VTN technology. By the end of the process, the bulldozer has been completely dismantled. What once was a massive machine is now reduced to piles of separated steel ready for transport to recycling facilities. The VTNCI 7000 proves its reliability, strength, and performance as a key tool in metal recycling and industrial demolition, combining productivity with environmental responsibility. The Drake 16 HP is the most versatile compact shredder on the market, designed by Bonfiglioli for efficient and flexible metal recycling. It offers a high degree of customization, allowing users to adapt it to various operational needs. Available in both diesel and electric versions, it provides excellent energy efficiency and significantly lower running costs compared to other machines in its class. Furthermore, the Drake 16 HP requires minimal civil works for installation, making it a practical and cost-effective solution for scrap processing operations. The IC35 steel shear is a compact yet powerful hydraulic cutting machine designed for processing automotive scrap bales. It is capable of cutting large metal bundles measuring approximately 700 by 1000 millimeters into two smaller and more manageable pieces. Built with a high-strength steel frame and advanced hydraulic components, the IC35 provides exceptional cutting force and reliability for continuous heavy-duty operations. During operation, the scrap bale is positioned securely on the shear bed. The hydraulic blade then descends with tremendous pressure, slicing through the dense material cleanly and efficiently. This precise cutting process not only reduces the bale size, but also prepares it for further recycling or smelting processes, NS. Thanks to its robust design and compact dimensions, the IC35 shear is ideal for recycling yards and metal recovery facilities that handle automotive scrap. Its efficient cutting action minimizes energy consumption while maximizing productivity, The IC35 represents a perfect balance of power, precision, and durability, ensuring safe and effective scrap metal reduction in modern recycling operations. The hot test steel rolling mill marks a crucial stage before full-scale production begins. During this phase, the entire system, from reheating furnaces to rolling stands and cooling beds, is tested under actual operating temperatures. Red-hot steel billets are heated to over 1,000 degrees Celsius and pass through a series of rolling stands to ensure proper shaping, alignment, and thickness control. Operators closely monitor parameters such as temperature, rolling speed, lubrication, and automation response. The purpose of a hot test is to verify that all mechanical, hydraulic, and electronic systems function smoothly and safely under real working conditions. It also allows fine adjustments to be made to improve product quality and process efficiency. Once the hot test is successfully completed, the plant is ready for continuous, stable steel production that meets industrial standards. The steel manufacturing process at Tannen Steel Works begins in the scrapyard, where approximately 25,000 tons of ferrous scrap are stored. Overhead magnetic cranes lift, sort, and arrange the scrap into designated zones according to size and quality. Once prepared, the cranes load the scrap into hoppers that feed the electric arc furnace 9. In the EAF, high current electric arcs generated between graphite electrodes melt the scrap metal. As the furnace starts, blinding arcs and flames fill the chamber while the temperature rises rapidly to over 1,600 degrees Celsius. Within about 45 minutes, the solid scrap transforms into molten steel. During this period, non-metallic impurities combine with fluxes to form a layer of slag floating on the surface. Workers periodically remove this slag, similar to skimming dross in cooking, to purify the melt. Operators view the process through protective lenses that filter the intense light and heat in. When melting is complete, the molten steel is tapped through a spout into a large ladle placed beneath the furnace. Each ladle holds about 70 tons of molten steel and serves as a mobile container for transfer to the next stage. The ladle is carried by a heavy transfer car to the secondary refining station, the ladle furnace. Here, refining and alloying operations fine-tune the composition and temperature. Alloying elements such as nickel, manganese, and chromium are automatically added through a conveyor-fed weighing system. This ensures accurate dosing of materials according to the target steel grade NNA. To achieve uniform chemistry, argon gas is injected from the ladle's bottom. The rising bubbles stir the molten metal, creating turbulence that evens out temperature and composition. This argon stirring also removes dissolved gases like hydrogen and oxygen, further improving the purity and mechanical quality of the steel. When the molten steel reaches the desired temperature and composition, samples are taken for laboratory analysis. The samples are quickly cooled and analyzed by spectroscopic instruments. Within about 30 seconds, the data are transmitted to the central control room. Operators immediately compare the results with specifications. If any deviation occurs, small alloying adjustments are made to restore the required composition. After refining, the molten steel moves to the continuous casting machine. The ladle pours the steel into an intermediate ton dish, from which it flows evenly into multiple copper molds, usually 8 strands operating simultaneously. Inside each mold, the outer layer of steel solidifies while the core remains molten. As it travels downward, cooling sprays and rollers guide the semi-solid strands until they completely solidify into long billets, roughly 10 meters in length and 1.5 tons in weight. Continuous casting allows uninterrupted production while minimizing waste and improving internal quality. When solidified, the billets are cut to fixed lengths by automatic torch cutters and transported to the rolling mill for hot working. Before rolling, they are reheated in a furnace to regain malleability. Once the billets reach the correct temperature, they pass through successive rolling stands, each equipped with rotating rolls that progressively reduce their cross-section. Through multiple passes, the billets elongate and thin out, gradually forming long steel rods. As the material flows through the final rolling stands, it is shaped into reinforcing bars, commonly called rebar. Their surfaces are embossed with diagonal rib patterns to improve bonding with concrete. Rolling speed can reach up to 60 kilometers per hour, ensuring continuous high-volume production. N. Immediately after rolling, the hot rebar undergoes controlled cooling to achieve desired mechanical strength. The bars are then straightened and cut to standard lengths, typically 4 meters. These finished bars, known as Type SD13, are relatively thin and mainly used for general construction reinforcement. Conveyors transport the bars along the production line to the bundling section, bot N. An automated tying system collects about 240 bars per bundle. Steel wire ties wrap around each group tightly to prevent bending or shifting during handling. The bundles move along an outbound conveyor, where alignment and quality checks are performed. Quality control is central to every stage of production. From scrap charging to final bundling, sensors, cameras, and digital monitoring systems collect real-time data on furnace temperatures, chemical compositions, and rolling dimensions. Any deviation triggers automatic corrections to maintain precise standards. The control room oversees all parameters through a centralized display network that integrates data from melting, refining, and rolling operations. After inspection, each bundle of rebar receives a label displaying the steel grade, size, heat number, and production date. This tag ensures full traceability back to the original batch of molten steel. Such documentation provides customers with quality assurance and allows the plant to maintain strict record-keeping for every ton produced. Finally, the finished bundles are transported to the product yard or directly loaded onto trucks for shipment. The logistics area is designed for efficient movement of goods, minimizing handling time and maximizing storage capacity. Throughout the entire process, Tannen Steelworks combines advanced automation with skilled human supervision. Magnetic cranes, programmable furnaces, automatic alloy feeders, and computerized casting machines all operate under continuous digital control. Yet, experienced operators remain essential, overseeing safety, making on-the-spot decisions, and ensuring smooth coordination between departments. From scrap selection to final packaging, every operation is optimized for productivity and sustainability. The recycling of steel scrap not only conserves natural resources, but also reduces carbon emissions compared to traditional blast furnace methods. The use of the electric arc furnace allows flexible production with lower environmental impact. The transformation of scrap into high-quality rebar thus reflects both technological sophistication and environmental responsibility. By controlling each phase: melting, refining, casting, rolling, cooling, and inspection. The completed rebar bundles are then loaded onto trucks or stored in the finished product yard, ready for shipment to construction sites and distributors. The entire production flow from scrap input to finished rebar output operates with high efficiency and precision, combining advanced automation with skilled human supervision.